let's talk about special forms. So, in the evaluation of a scheme expression, we need to know what sort of expression it is. Calculator just divided expressions into numbers and call expressions, but in scheme, there are some other alternatives as well. So the scheme eval function dispatches on the expression for it, meaning that it has just a bunch of different options of what it does, depending on what sort of expression it gets. Symbols that are bound to values in the current environment. Self-evaluating expressions are returned. Those are things like numbers and the empty list. Everything else is going to be a scheme list, called a combination. So we call it a combination just to say that it's a well-formed scheme list that's part of some scheme source code. And some examples are the if expression, the lambda expression, the define expression, and just a regular old call expression. So if you see a combination that starts with if, then you know it's an if expression. So special forms in general are identified by the first list element, if, lambda, and define. And if it's not one of these that we know about already, such as lambda and define, then we know it's a call expression. And so we just evaluate the operator, which might be a built-in name or a name we've defined. That gives us some procedure to apply to the arguments, which are the values of these operand sub-expressions. Okay, so now we can do something that we couldn't do in calculator. We can define a new procedure and call it. So here's one called demo. Takes in s. If s is null, then it returns the list 3. Otherwise, it builds a new pair with cons. That's first element is the first element of s, and the rest is whatever we get back from a recursive call to demo on the rest of the list. And we might call that on, for instance, 1, 2. Now what does this do? Think about it for a minute. This function demo puts a 3 at the end of the list that's passed in. Well, actually, it constructs an entirely new list with all the elements of the original s, 1 and 2, as well as the element 3. Because the base case gives us back 3, and then we just start consing on each element at a time in order to build up a full list that ends in 3 and starts with whatever elements were in the list that was passed in, and does this all recursively. So, it says we're supposed to do a demo. Let's do a demo. What you see on the right is your project 4 main file called scheme.py. And what does it do? Well, it has eval and apply functions, and scheme eval evaluates a scheme expression, which could be one of a number of types. We could have just a number, or we could have a combination. So let's see what happens when we trace this, and then we start up our scheme interpreter. So the number 2 involves a call to the scheme eval function with 2 as the expression. It's evaluated in the global frame, and the result is 2. If instead I negate 2, then I'm evaluating this whole thing. I'm putting this in angle brackets to say that this is not a Python expression, but a scheme expression. So negative 2 is evaluated by looking up the thing that negates. The number 2 is evaluated, and then we're applying negative to 2 in order to get negative 2. And we can do this larger example as well. So we'll define demo of s to be a procedure where first you check and see if s is null. If it is, then just return the list that contains 3. Otherwise, let's make this window bigger. We will return what we get by building a pair out of the first element of s, and then calling demo on the rest of s. Close the cdr, close the demo, close the cons, close the if, close the define, and we're done. Notice that scheme eval hasn't actually evaluated the body of this procedure yet. All it's done is create the demo procedure. So now let's see what happens when I call demo on the list 1, 2. A lot of work happens. Let's try to trace through what it is. So at the very beginning, I called demo on list 1, 2, which means I'm evaluating this expression, which is a call expression. We figure out what demo means. Demo is a function that has the body that we wrote down before. And we figure out what list 1, 2 means. After a bit of work, we find out that it's the list 1, 2. So now we're going to do the work of applying this procedure to this argument. So that involves evaluating the body of the procedure in a new environment where S, the formal parameter of our procedure, is bound to the argument 1, 2. And this frame is followed by the global frame in the environment for this call to scheme eval. Okay, so some work ensues, and we're not going to trace through every bit, but it involves looking up every name. Null is the null procedure, 1s is bound to 1, 2, so we look that up, etc., etc. Work is done. Each time we make a recursive call, we're making a recursive call to the same procedure, but with a different environment. So notice here, s was bound to 1, 2. But in a later recursive call, s was bound to 2. And in a further later recursive call, s is bound to the empty list, which is the base case. We detect the base case here, and we return this base condition of just the list containing 3. Okay, so we've returned that. We now build a larger list, which puts the number 2 on the front. Remember, this is the case where s is bound to 2. So the first element of s is 2, and we put that on 3 to get 2, 3. And then we have, still later case, the original recursive call had s bound to 1, 2, which constructs the list 1, 2, 3. And eventually, we get the result that we want.